Hello and welcome to Eyes on Research, the podcast that digests the latest scientific innovations in eye research using simple and understandable terms. I am your host, Thales Guimaraes, medical doctor and clinician scientist at Moorfields Eye Hospital. Hello and welcome to another episode of Eyes on Research. I hope you've had a wonderful week so far. I'm not sure if you have seen, but we have very nice topics scheduled up until June. The lineup is looking really good. You can find the full schedule on our support website that's linked in the description of this episode. So, the question that we are trying to answer today is, are people actually becoming more short sighted, right? And if so, why is that the case? Well, this is definitely not a myth, and short sightedness is indeed a modern epidemic. Short sightedness, nearsightedness, myopia, these all mean the same thing. This is a type of refractive error, meaning that something about the natural shape of your eyes makes your vision blurry. Now, if you follow this podcast, you will have heard many times this crazy host talking about the process of seeing. You will remember that the way that we see things is that light that's bounced out by objects comes right straight into our eyes and crosses the entire media of the eye to reach this film-like tissue that we have in the back of our eyes named retina. The retina is a sensitive tissue that has many cells that react to light, right? It's a light sensitive tissue. We call this photoreceptors. These are triggered by the photons of light, which generates an entire and complex cascade of events that ends up with the electrical activity being sent to the brain via the optic nerve. Well, when you have refractive errors, what is actually happening is that the light is not focusing directly on the back of your eyes, on the retina. So, patients with refractive errors, they have a blurry vision unless you correct them with glasses. And by the way, just to get this out of the way, because that's a question that we typically get from patients, and also something that they say very often, refractive errors are not a disease, right? Being farsighted or being nearsighted or having astigmatism, for example, this is not a disease. You can maybe consider it more as a misalignment of the optic system that is the eye, right? Myopia is not the only type of refractive error there is. There are others, as I just said, farsightedness or hyperopia, and astigmatism are other examples of that. We have a full episode coming soon next month, in 3 weeks, I think, about refractive errors and why people need to wear glasses. So, let's leave this discussion to that specific episode. So, people have myopia when the refractive power is too strong for the size of the eye. In most cases, this happens because of an axial component, meaning that the eye grows slightly too long, or in other words, the eye is too big for the refractive power, too long for the refractive power, with the light focusing before the retina. Currently, the worldwide prevalence of myopia exceeds 28%, with estimates that it will affect half of the population by 2050. That's such a huge number that it escapes comprehension. We're talking about 5 billion people affected with myopia by 2050. That's our estimate. It's crazy, isn't it? But the question that remains, I think, is why do some eyes grow too fast? Right? Why are they getting long too fast? What's the cause? Right? The swift increase in the prevalence of the disease combined with the national differences, right? Meaning that the rate that this is happening in East Asian countries, for example, such as South Korea, China, and Singapore, are different than what's happening in the Western world. We can't really explain that only based on genetics. And it turns out that in some animal models, dopamine antagonizes the stimuli for eye growth. And dopamine is a specific neurotransmitter that does many things in the body. Very important neurotransmitter. These findings were then combined with the findings from a group at the Ohio State University that there was an association of spending time outdoors with myopia, with short-sightedness. Subsequently, a group at University of Sydney hypothesized that the protective effect of spending time outdoors is caused by a light-triggered dopamine release under brighter lighting settings. This is all to say that spending time outdoors is actually a protective factor in the development of myopia, of short-sightedness. And why is this important? Well, there's something that we call high myopia, which we consider to be people who have 6 or more diopters of myopia, right? And these people have a considerably higher risk of things like retina detachments, right? Just to give you an idea, people with high myopia are 20 times more likely to have a retinal detachment than people who do not have myopia. And then in the far end of this spectrum, we have patients with something called malignant myopia or degenerative myopia or pathologic myopia. They all mean the same thing. This is a disease, or actually, should I say, a degeneration that actually leads to scarring in the back of the eye and permanent vision loss. It leads to atrophy. So that's why this is important. So, what are the risk factors for myopia and myopia progression? Well, firstly, age, right? So, kids with more or equal to 1.25 diopters of myopia, but particularly if aged 6 to 7 years, are at a higher risk for faster progression. The COMET study, which was short for the Correction of Myopia Evaluation Trial, was a multicentric randomized control clinical trial evaluating whether there was a difference in the progression of of myopia between children wearing progressive additional lenses versus conventional single vision lenses. That's all very interesting, but what I would like to mention about the study is that one of the things that it actually reported is that the main age when myopia stabilizes is around 15 years of age, 15.6 to be more precise, which is interesting. The second factor is ethnicity. As I said before, depending on where you are in the globe, you have a higher prevalence of short-sightedness. So, for instance, in East Asian countries, there's a 2 times higher prevalence than in the Caucasian population. In fact, there are some regions in East Asia where the prevalence exceeds 80%, meaning that 8 individuals in 10 have short-sightedness, have myopia. How crazy is that, right? The third risk factor is having parents that also have myopia. A study published recently analyzed all the evidence reporting the genetic contribution to the development of myopia in kids. And by the way, this type of study is named a meta-analysis. And we consider this the highest form of evidence there is because it essentially summarizes our studies after a very didactic and a very specific search, and then it does statistics for this so that we can have a better grasp of what we're trying to look. And on this case, it was the risk of myopia in parents who also have myopia. So the study found out that the odds or the risks of developing short-sightedness are 1.87 times greater compared if you had no parents with short-sightedness. And if you actually had two parents with short-sightedness, that risk increases to 2.4 times. So there's definitely some genetic influence on the development of myopia as well. And then the last one, environmental factors. This is why we call this a modern epidemic. As we just discussed, increased outdoor time is protective in terms of myopia incidence, right? Remember the dopamine effect? But it is not effective in slowing down the progression in eyes that are already myopic. Also, reading or doing close up things for a long time has been associated with an increased risk of developing short sightedness. And guess what? We all live in the era of technology. We all have our computer screens, our television, our cell phones are in our pockets, and we use them all the time. It's just the way it is, right? So, this is a risk that's extremely hard to control, and possibly the main reason why people are becoming more short sighted. But research wise, there are indeed several treatments being investigated, from overnight rigid gas permeable contact lenses to multifocal contact lenses, all the way to eye drops, right? And the eye drops are very promising. A particular type of eye drops named atropine has been showing a lot of promise and effectiveness in some studies. Atropine is a drug that relaxes the eye and increases the pupil diameter. So, because of the commonality of the disease, there are a lot of research groups trying to treat this, and we are very optimistic and hopeful that the future is indeed bright. I think we're getting there. Thank you so much for listening to me today. I should also say that we have social media accounts where we post very short videos about teams that did not go on to become a full episode. So visit us on @EyesOnResearch on your favorite social media, Twitter, TikTok, Instagram. We have it all. Also, you'll find the link in the description of this episode to our blog. It's a Buy Me a Coffee website. Now, please consider subscribing to us there. It's completely free, and we are using that platform as a blog, right? So you'll see weekly posts about curiosities and trivia about the eyes and vision, as well as hot research updates on topics that, again, did not go on to become a full episode. So please do consider subscribing. Our mission here is making science more accessible to the population, so it is free and always will be. However, we are also self-funded, so if you have the means to, you can certainly donate in our Buy Me a Coffee website, which, although optional, is highly appreciated. And you get access to cool things, right? Cool perks like special posts, episode transcripts, and other cool things, like, for instance, suggesting themes for blog posts, short videos, or even full episodes, right? Anything that piques your interest, really. So please consider checking that out by clicking the link in the description of this episode. Otherwise, share the podcast widely amongst your friends and family, and make sure to give us a rating if you like what you do. This helps us a lot. Big shout out to one of our supporters, Dr. Angelos Kalitsios. Thank you so much for your support. Thank you all very much, and I'll see you in the next episode. Bye bye.